So there's going to be, I want to give you a height problem. And this will be posted. Let's say that height is normally distributed. The mean height for most people is 68 inches. What symbol would you use to represent the mean height? Would it be an X bar or a mu? The mean height for a whole group. Let's pretend we're a population here, so it's a mu. So, right, mu equals 68. The standard deviation for this group is 6. What symbol would you use if this was a population? For the standard D, what symbol would you use? Would it be an S or would it be a sigma? It would be a sigma because it's a Greek population. It's a population. So sigma is 6. My question for you is this. What is the probability of randomly getting somebody taller than 80 inches? What is the probability of getting someone taller than 80 inches? Greater than 80 inches. So let's kind of discuss out loud some of the logic here. What would be going through your mind here? Are there any formulas that you would want to be trying to plug things into? By the way, my 12th grade pre-calc teacher, Rosie Chimera, said never say the word plug in. So I always say the word plug in now. Because why not? You got values. What have you got here? You've got 80. Getting somebody, what would 80 represent? Would that be a mu? It'd be kind of a score, an X, right?
Yeah.
Mean 68, and you got a standard D of
6.
6. So what formula would you try to use here? The z-score formula. So the first thing you would probably try to do is get a z-score for this situation. A z-score for this situation. And as most z-score formulas would be, I'll usually give you some pretty easy math. If you find something getting very weird, either I screwed it up or you better double check yourself. 80, 68, and 6. What do you get there? Did you get a 2?
Yes.
80 minus 68 is 12 over 6. Z-score of 2. So you get a z-score of 2, but what did the question ask you? So you get your z-score first. Partial credit is always given. Z-score of 2 is what you get. You want to show that. And then what did the question ask you?
Probability.
The probability of getting somebody
80 inches.
80 inches or taller. So let's pretend you don't know what you're doing. What would you do next? What did we just learn about here? Get a z-score at the end. What do you do at the end? Look it up in the book, right? The unit normal table. Z-score of 2.
Pretty low.
So the z-score of 2, and if you, I always find it useful to make the charts here, and I make them as poorly as I can. Z-score of plus 2. So the idea of randomly getting somebody greater than 2, should it be 16% or higher or lower than that? Should it be more than 16% or less than 16%?
Less than.
It should be less than 16%. If you always have the 0, 1, and 2 kind of in your mind, you'll always kind of have a map, and it works kind of the opposite way on the negative side, but it's still the same thing. So a z-score of 2, how much is left out here, according to your book? 0.0228, or 2.28%. So what are the odds of getting somebody taller than 80 inches?
2%.
About 2.5%. About 2.5%. So if you are asked a question like that, what's the probability of getting somebody greater than this or less than that? You do what? You get a z-score first, you look in the table, and then you figure out kind of the percentage in the tail. What if I were to ask you, what's the probability of getting somebody less than 80 inches tall?
Pretty good.
Pretty good. If the probability of getting somebody greater than 80 inches is only 2.5%, what's the probability of getting somebody less than 80 inches? 97.5%, usually rounded to about a half. So the more extreme our z-score, the further out we are. Let's actually go for one more case here. Remember that case I drew a few minutes ago? Let's give you the case of the class mean in physics is 40. My score was a 45, and the standard deviation is 1. The standard deviation is 1. I got a 45. The class mean is 40. Would I be happy? My score was a 45, the class mean was a 40, and the standard D was 1.
I would say so.
You would say I would be happy. Where would I be in this picture?
Pretty high up.
Woo-hoo! Z-score equals 5. What percentage of the class did better than me?
Practically none.
Does it go to a z-score of 5?
No.
No. It goes to a z-score of what? 4. And what percentage did better than me if I got a z-score of 4? You move the decimal point 2, less than 0.000003. So I obviously got the best score in the class. So that is good. So a z-score of 5 is really good. 45, 40 if the standard D is 1. That's great for me. What if it was the other way? What if the mean was 40 and my score was negative? What if my score was negative 35? I'm sorry, 35. It would be much more negative in that respect. If my score was a 45 and the class mean was a 40, would I rather the standard D be 1 or 5? My score was a 45, the class mean was a 40. Would I rather the standard D be 5 or a 1? 1, because if it's a 5, then I just got a z-score of 1. That means some other people were up there. But if my z-score is a 5, that means I did better than everybody. Woo-hoo. So, z-scores are pretty useful. And let's see. Yeah, you'll have one homework problem to do. Why don't we just go ahead and do it here. IQ. For IQ, we know that the mean is, what's the mean IQ?
For population.
Yep, population. What's the mean IQ?
100.
100. So we know mu is 100 and standard D is 15. What is the probability of getting somebody just randomly to have a score greater than 115? What's the probability of getting somebody to have a score greater than 115? Oh good, just like a good lecture, we put Junior to sleep. It is statistics. What is the probability of getting somebody with an IQ score greater than 150?
Almost.
So the IQ mean is 100.
Right. It's 150.
You got a score of 115. So what do you do first?
I go see or find the z-score.
Find the z-score first. 115 minus 100. You know it's got to be positive because your score was greater than that.
Okay.
Over what?
15
15. So what's your z-score? 1. Z-score of 1. So what's the probability of getting somebody a z-score of greater than 1? You can just kind of remember your key values here. It could happen 16% of the time. You could look it up in your, 0.1587. And remember, if you get confused by the decimals, if you are given something on a test that's like a more middle number, just go back to the z-score of 1 and look at the 0.1587 and remember, oh, that's almost 16%. Just move the decimal over. So, yeah, the probability of getting somebody greater than 1 is about 16%. What is the probability of getting somebody between an average score and 115? What's the probability of getting somebody between 100 and 115? It's 34. If you always know that z of 0 is 50, I'm not going to get this too complicated for you. The idea, though, is very important. Z-scores are the building blocks. After the next test, you'll have a lecture to listen to, and the idea of z-scores, it's an important idea. Z-score of 0 means you scored right at the mean. The more extreme your z-score is, the further out from the mean you are. What we're probably going to end up finding down the road, even if you remember back to the chi, we're going to try to evaluate after the test this idea of statistical significance. Do you think to be statistically significant you want to be close to 0 or more extreme? To be statistically significant,
More extreme.
you'd actually want to be more extreme. So you could almost picture the 80 versus 20. The higher your values are on anything, the further away from chance or the middle you're going to be, and that'll be a good thing. So this idea of the z-score, I won't need you to do all these computations and stuff, but the 0, 1, and 2, did you do better? The negative means something here. If you get a negative value doing a chi-square, what can I tell you? You screwed up because everything is squared. If you get a sums of squares, variance, or standard deviation of a negative value, what can I tell you there?
So did
You
something wrong.
screwed up.
It's supposed to square it.
Everything is squared, but on z-scores, the negative value does matter. You'd rather have a smaller negative value if it's this situation than a positive one. So, okay, let me stop this.